Hello.
Hi, Andy.
We are over 6 feet apart, and we have a shield, so I'm going to take my mask off so you can hear what's going on.
That was so incredibly loud, Nate.
So thanks for joining us. Today's episode of Lunch with Andy is about batteries and battery stuff. We had pizza today for lunch. This is my favorite pizza today from Harvey Hinkleminers. So FRC batteries look a lot like this. They are 18 amp hour batteries, 12 volt, sealed lead acid batteries. None of this lithium ion, lithium polymer, none of that on FRC robots. Check the rules, make sure your batteries comply with the current year's rules. Do not cover the vents on the top or this vent plate, and just check out your battery, make sure there's no bulges on the side and no liquid or any kind of a wetness coming out of the top. Once in a great while you'll see that as a defect in a battery. Those are the same things to look for.
Or corrosion around the terminals.
Yeah. Some of your older batteries, like we saw one on our team, sometimes even under your heat shrink or your insulated tape, electrical tape, there's corrosion on the terminals. You gotta use the same connector on all the batteries.
SB series is
SB series.
So these are SB50s. We also have the SB120 for the 4-gauge wire. Pick the one your team wants to use. Make sure all your chargers and your robot are the same standard so everything works together. The pink ones in the kit are the same as the red ones. These are just the donated ones.
The smallest wire that you can use is a 6-gauge wire. I've seen a lot of teams using 4-gauge wires, and we sell a series of 4-gauge wire battery cables and robot side cables too. So 6-gauge is the smallest, 4-gauge is larger and has less resistance. That's the idea of getting slightly more power to your battery from your battery to your robot with less resistance over a 4-gauge wire. There's some things to do with your battery to maintain it and keep it legal. Oh my gosh, here is a 4-gauge connector, SB120.
So that's the one we saw. I don't even want to. This is scary. So I don't even want to. This is scary.
Especially if you have a charger, a battery charger, and you want to charge your batteries that have the SB120s. This was the charger. You'd plug that in and then plug this into your battery over here, because our chargers have this as the standard connector. Some things to look for besides the cable and the connector. You got to have your terminals insulated. So we have a nice insulated pack. We have a heat shrink that's cut to the right length and it has the right diameter. You can use that. Also, I see a lot of teams using electrical tape. Before you insulate these terminals, you got to make your fastening technique very robust and solid. You don't want these to move around at all.
The hardware that comes with the battery is all right. I don't like Phillips screws. The nuts are not locking nuts, so I don't really like that hardware set. So we developed this battery hardware kit. 2 of the right length screws that are socket heads, so you can really tighten them down well. Lock nuts to keep them from vibrating loose, and the appropriate washers and the star washer to get a nice interface between your cable and the battery lug. That all goes in here, and then before you put that on, you gotta slide the heat shrink over the tube so that you can then slide it back down later. So we've got the 2 black ones here have glue inside of them to keep everything nice and rigid at the connection, and then we give you a piece of red to cover the black so that it's you don't have 2 blacks.
The red side.
Terminal there. Yeah. People have asked for additional stickers. I guess maybe they mess up theirs or something, so we just threw a sticker in there as well. But these come with all the batteries, so you can write the date when it started and sort of keep track of what battery is what.
And this sticker helps you maintain your batteries also. It tells you what to do before the match, after the match, what not to do with the battery. So there's, for your new students on the team, the stickers will help you show them how to treat a battery. One of the things that really drives a lot of people crazy is when you grab a battery. I see people running around pits sometimes and pulling up the battery with the battery cables. Notice I'm not doing that, but don't hold it just like that. Do not carry a battery around by the cables. There's a lot of things going on with the terminals and the structure inside the battery. First of all, it's going to loosen your nuts eventually and your screws, and also it's going to tear up the structure of the posts and the terminals inside the battery. So don't do that. Okay, so those are pretty simple things. Getting a little more complex is, how do you know if a battery is a good battery or not? How do you know if they're charged, if they're good, if they're bad, if you want to use them, right? So there's different ways to tell. First of all, you can always go with a voltmeter. You can plug in, touch those leads. You can tell how much voltage is on the battery. That takes a very expensive tool, and it's kind of a pain. So we have some other ways to do that. First of all, you have a Batt Hawk that you can plug in, and it shows you right away the voltage. This is 12.7. It's a little bit low. I'd rather it be like 13.1. But if that's charged and I know it's charged, I can use this somewhere else, and I can put in a battery flag invented by Alan Anderson on Technocats about 20 years ago. You can use a battery flag. You can say, hey, everybody on my team, this battery is charged because it has a flag in it. You don't have to test it because I tested it this morning.
We don't have any markings on these that say charged or anything, just the HandyMark logo. You can agree on your team what that means. That could mean you've checked it with a battery beak and it's above a certain number, or you can say it just came off the charger, and maybe at the end of the night you unplug them all. If you're superstitious, they're going to drain a little bit or something. So just agree on your team what that flag means,
right.
And everybody will know.
Yeah, we used to use tape, electrical tape, years ago, but this is a much better way. To get really a little bit more data than just the voltage, you can use a battery beak, which is a more expensive device, but it's a very compact battery checker. I'd say it's for match-to-match checking of the batteries to make sure the condition of the battery is where you want it to be, and if it can hold a charge for any amount of time. It doesn't do a full test that you might want to do on a battery, but this is good for competition tests between matches and between days on a battery. So you just plug it in, it gives you some data on the readout. So then we have this Cba Tester. It's been a very popular tester for batteries in FRC, but only really a few teams were using it. I didn't know much about it. I knew that it was out there. Nathan convinced us to distribute it, and he knows more about this than I do. I've never used one. It's pretty simple to use from what he says, so that's why he's here to tell us all about it.
It really is plug and play, basically. So if you go on the webpage for it, and it outlines all these steps, but basically you just install the software, plug the USB cable in, plug the battery in, and then you go here, open the software, start test, and then you can detect what battery you're using. So it's detected that this is a nominal 13.2 volt battery, 6 cells in it. We do have to tell it that it's an 18 amp hour battery. It'll populate the cutoff voltage for the test is 10.5 volts, so that means it'll discharge it down to 10.5 volts and test it over that period. Test amps, the most this can do on these batteries is 7.5 amps. So in FRC, we're drawing way more than that, but only for 2 minutes. And this little heatsink here can't take that. So it's going to draw 7.5 amps over the course of the test.
It's like 2 hours, right?
Yeah, it's a pretty long test. So this is like, for our team, we do this about once a year, just to kind of rank all our batteries 1 through however many batteries we have, and then we'll know to use the good batteries if they're available, if they're charged. If not, we'll just go down the list.
Since you're only testing this once a year, a lot of teams name their batteries. So this is AL or AL, very creative. That's AF. Yep. So there's AA, AB.
Yeah, a couple years ago we started A, B, C, and we're at AF now or whatever. So that's where under test name you put the name of the battery, and that'll show up on the graph as that's what this battery was at this date. And then so once you have all that filled in, you just press start, and you see it spin up and get your graph starting. So it started at a little over 13, and that was basically just a surface charge, and then it's dropped almost immediately to 12.5. So you can see this line kind of peter out over a couple hours. The bottom is amp hours, so that's like total charge in the battery. So that's decreasing, or that's going over time. And you'll see the graph go down, gonna go across, and then peter out, and then it'll cut it off at the cutoff voltage of 10.5. And then basically, the farther out the line got, the better the battery. Yeah. So I mean, you can say the really bad ones, if you find, and these graphs should match sort of your performance data. If you put the battery in the robot and you're driving around for practice and it starts stuttering after like a minute of driving, and it's also the lowest on the curve, you should probably just take the leads off and recycle that battery. That's going to be a goner.
Thank you, Nathan. This has been very informative. Hopefully we've all learned something and you can perform better with more knowledge about your batteries.